Can the event loop be blocked, and in which situations does this happen? The event loop itself is a scheduling mechanism, but it can be effectively blocked when the call stack never becomes empty because the event loop can only schedule new callbacks when the stack is clear. What exactly exists is a single call stack executing synchronous JavaScript, microtask and macrotask queues holding callbacks, and the event loop waiting for the stack to be empty before moving work into it. The order is strict. Synchronous code runs on the call stack. If a long-running computation, infinite loop, heavy JSON parsing, or deep synchronous recursion occurs, the execution context stays active, the call stack remains non-empty, and the event loop cannot proceed to process queued tasks. This means timers, promise callbacks, network responses, and user events remain in their queues because the event loop checks the stack, sees it is busy, and waits. In the browser, this blocks rendering because layout and paint steps require the main thread to be free, so the UI freezes. In Node.js, this blocks incoming request handling because the server cannot move to the next phase of the loop. Microtask starvation can also effectively block progress, because if microtasks continuously enqueue more microtasks, the event loop keeps draining them and never reaches macrotasks, delaying timers and I/O callbacks. The causal chain is heavy synchronous task or unbounded microtasks occupy execution. Call stack or microtask queue never clears. Event loop cannot advance phases, asynchronous callbacks and rendering are delayed. For a software engineer, this means avoiding CPU-intensive synchronous work on the main thread, splitting tasks into smaller chunks, or offloading heavy computation to worker threads to prevent blocking the loop. The event loop is blocked whenever the call stack or continuously refilled microtask queue prevents it from reaching the next scheduling step, stopping timers, I/O, and rendering from executing.